Hi class. This video is going to be about the quadratic formula and the discriminant. The quadratic formula is a formula that we use to solve quadratic equations. It can be used to solve any type of quadratic equation, unlike factoring where you have to have a certain type of quadratic or square roots where you can't have a linear term. Quadratic formula can be used to solve any type of quadratic equation. So the first thing I'm going to show you guys is a story that you can use to help you remember the formula. You do not have to remember it this way. In fact, I want you guys to, as a project, I want you to come up with either another comic strip, or maybe you could come up with a song or something like that that would help you remember the quadratic formula. But anyway, here is a story that I've used before to help students remember the quadratic formula. So it's a story about a boy. There once was a negative boy named Boo. You see, he says, "I hate everything." And down here you can see where the formula starts to come together. So there once was a negative boy named Boo. He couldn't decide if he wanted to go to this radical party. In the end, Boo decided not to go because he's a square and he missed out on 4 awesome chicks. And the party was all over at 2 a.m. You snooze, you lose. All right, and here's the whole formula here. So going back, the negative boy, that gives you negative B, or we'll say opposite B. Then he couldn't decide, that's the plus or minus. Go to the radical party, that's the square root sign. Because he was a square, that's B squared, and he missed out on 4 awesome chicks, that's the minus 4AC. And the party was all over at 2 a.m. So all over 2A. Okay. All right. So make sure you have your paper and pencil out. Make sure you're copying down these notes for your future reference and for help on your assignments. When you ask for help, I'm going to direct you back to your notes. So make sure that you have copied them down so we both have something to go from. All right, so the quadratic formula, as you just saw, is opposite B plus or minus square root of B squared minus 4AC all over 2A. And we get our A, B, and C from the standard form equation, AX squared plus BX plus C equals 0. That's the standard form of your quadratic equation. So always make sure that your equation is in this form before you start doing the quadratic formula, because it's very important that you put the numbers in the correct place. Okay. This part underneath the radical is called the discriminant, and that can be used to tell you what type of solutions you have, and we're going to get to that at the end of our notes. All right, so our first example, we're going to do an example of a quadratic equation with two real solutions. So our quadratic equation was 2x squared plus x equals 5. Um, First of all, this is not in standard form. It does not equal 0. You have 5 on this side. The 5 should be over here. So we're going to subtract 5 from both sides to make this in standard form. Now we have it in standard form. Okay. So now we can label what our A, B, and C is. So A is 2, B is 1, and C is negative 5. All right, once you have labeled A, B, and C, then plug them into the formula. The formula is, again, opposite B plus or minus square root of B squared minus 4AC all over 2A. So you're going to plug it in. So I'm plugging in 1 for B. Hold on, go back up some. All right, so I'm plugging in 1 for B plus or minus square root 1 again for B minus 4 times A. I'm plugging in 2 for A. And then times C. C was negative 5. And then all over 2 times A. Our A was 2. So 2 times 2. All right, the first thing you want to simplify is the discriminant. Okay, the discriminant is 1 squared minus 4 times 2 times negative 5, which gives us 41. So that's where this 41 comes from. All right. And then opposite 1 is going to give you negative 1. And then 2 times 2 is going to give you 4 on the bottom. So I don't have any radicals in the denominator. 41 can't be reduced anymore. So my final answer is negative 1 plus or minus the square root of 41 over 4. And my two solutions are negative 1 plus the square root of 41 over 4 and negative 1 minus the square root of 41 over 4. All right, let's go to the next one. So pretty much what you're doing, you have to, the most important part here is making sure you label your parts correctly and you plug them into the formula correctly. After that, you just have to simplify um, and simplify any square roots or anything like that. All right, here's an example with one real solution. Our equation was x squared minus x equals 5x minus 9. Is this in standard form? No. Okay, it is not in standard form. So we have to move some pieces over to the left to get this in standard form. So I'm subtracting 5x from both sides. Negative x minus 5x gives me negative 6x. And then I have to also add 9 to both sides. And that gives me that gives me x squared minus 6x plus 9 equals 0. Now I can label my A, B, and C. A is 1. B is negative 6 and C is 9. You see that here. There's no number here, so that's an understood 1. B is negative 6 and C is 9. All right, plug it into your formula. So opposite B is going to give me opposite of negative 6 plus or minus the square root of B squared. That's going to give you negative 6 squared minus 4 times A. That's going to be minus 4 times 1 times C, which is 9. And then all over 2a, so that's going to become 2 times 1. All right, simplify the discriminant first. That's going to give me negative 6 squared. Make sure you are using your parentheses when you plug this into your calculator. If not, you will not get the right answer. Use parentheses. Okay. All right. So negative 6 squared minus 4 times 1 times 9 equals 0. And so then that's going to give me the square root of 0. Opposite of negative 6 is positive 6, and 2 times 1 is 2. And so now I just have 6 over 2, because the square root of 0 is just 0. And then 6 over 2 is 3. So my solution is 3. Now remember that quadratics always have two solutions, and we'll get into like what this looks like on the graph and things like that in our next lesson. But for right now, I want you guys to know that 3 has what we call multiplicity, meaning it occurs twice. So you would say the solution is 3 with multiplicity 2. All right, last example is a quadratic with two imaginary solutions. So remember, your imaginary number comes from having a negative number underneath the square root. So we're going to see how that happens as we solve. First of all, we have negative x squared plus 2x equals 2. Is this in standard form? No, it is not. Okay, you have to get this 2 over to the left-hand side, so we're going to subtract 2 from both sides. That gives us negative x squared plus 2x minus 2 equals 0. Now I can do my a, b, and c. A is now negative 1 because I have a negative in front of x squared. B is 2, and c is negative 2. Okay, plug that into my formula. I'm going to get opposite of 2 plus or minus square root of 2 squared minus 4 times negative 1 times negative 2. And it's going to be all over 2 times negative 1. First, you're going to simplify the discriminant. Okay, 2 squared minus 4 times negative 1 times negative 2 gives me a negative 4. So that's going to leave me with -2 plus or minus the square root of -4 over -2. The square root of -4 we know is -1 times 4 by our product property. And anytime you see a negative under the square root, you're going to take out I, the imaginary unit I. So now you have I square root of 4, and the square root of 4 is 2, so you have 2I. So this becomes -2 plus or minus 2I over -2. And you can keep simplifying because you don't have any radicals. You can just reduce this fraction by finding a common factor. What do -2, 2, and -2 have in common? They all share -2. Okay, so you're going to divide everything by -2. This is going to give me a +1. This is going to remain plus or minus because when you divide by -2, the signs are still going to come out plus or minus. Like a +2 divided by -2 is -2, but a -2 divided by -2 is +2. So you still end up with that plus or minus. And then so this becomes just I, the twos cancel out. Okay, and so your solutions are 1 plus I and 1 minus I. All right. Lastly, the discriminant. So as we work through these examples, you should see that there were three types of discriminants. The first example, we had two real solutions, and our discriminant was greater than 0. I'll go back and show you. So our discriminant turned out to be, oh, wait. Our discriminant turned out to be 41, I believe. Yes, 41, and that is definitely greater than 0. And what type of solutions did we have? We had two real solutions. They were irrational, but they're still real. Okay, the next one, we had a discriminant that was equal to 0. Okay, our discriminant was 0, and we only had one real solution with multiplicity, of course. Okay, and our solution was 3 there. And then we had a discriminant that was less than 0. It was -4. And then we had two imaginary solutions. Okay, so I want you guys to copy down this chart here. If you have a discriminant that's greater than 0, you have two real solutions. If you have a discriminant that is equal to 0, you have one real solution. And if you have a discriminant that is less than 0, you're going to have two imaginary solutions. All right. Thank you guys for watching. And if you have any questions, just email me or ask Miss Wiles or Miss Elliott, or you can ask me on Wednesday during our Google Meetup.